Hello, my name is Caleb and this is Lab 4, Oscillations. The purpose of this lab is to investigate the motion of a spring mass system with the mass oscillating in an arc. GlowScript was used to make a computational model to predict or graph the object's position, and Tracker was the software used to track the observed position of the object during the experiment. Some of the fundamental principles in this lab include Newton's second law, which explains how a system's change in momentum is proportional to the net force applied, and the energy principle, which explains how a system's change in energy is the sum of the work done by surroundings and thermal energy exchanged with the surroundings. Some useful formulas include the formula for kinetic energy, gravitational potential energy, a spring's potential energy, the velocity update formula, and the position update formula. This slide contains the video that was used to track the data in Tracker, and the two graphs on the left contain a visual of what the motion of the object looked like during the video. And finally, it includes a loop used to calculate and predict the motion of the object over a period of time. This slide contains the graphs that compare the computational model of GlowScript to the experimental data from Tracker. As can be seen, the two plots are almost exactly the same with a very minor difference. The only difference in the y position graph is the initial position of the computational model, which caused some discrepancies. However, the motion of the plots are still the same. On the far right is the model of the oscillating system that was computed by the GlowScript code. We can determine that the energy principle is satisfied because no external forces affect the isolated system and the change in energy is zero throughout the model, as can be seen in the graph. These are the estimations of the oscillation periods of the x and y directions. It was determined through the calculations that choosing different directions would produce deviations in the period, ultimately affecting the spring constant and the graphs. Finally, some of the possible errors include an inaccurate center of mass placement on Tracker, which could cause deviations, and there is not truly zero interaction from the surroundings in a real scenario, so the work done by the surroundings could cause deviations as well.